Hey, my name's Brendan Young, and today we're talking about diesel versus petrol engines for automotive use. So first we're just going to talk like brief introduction, talk about their application, then we're going to go into some theory behind internal combustion engines, and then the thermodynamics of each, and then a comparison between the two different types of engines. So whenever you think of diesel, you probably think of one of these three pictures, either the green gas pump that you always see that's really dirty, or you think of a big 18-wheeler, or you think of some high school kid blowing black smoke out of a truck that dad bought him. But nowadays, I'll start out, which one of these vehicles is diesel? Any guesses? We have engineers, so yeah. You guys actually probably have heard that more cars companies now are coming out with diesel engine cars, so it's, not only is diesel engines trucks nowadays, a lot of German, I know like Volkswagen, BMW are definitely doing this, putting diesel engines in cars. So today, I know back in thermodynamics that we talked a little bit about diesel engine cycles. But I wanted to dive in, like, what is a diesel engine? How is it different than a regular petrol engine? So just as like a picture, this is an LS engine. This is a V8 engine. It runs off regular gas or petrol. Then on the which would be your left, there's a diesel engine. So this is a common inline 6. Cylinder diesel, and then this is a V8 engine, like I said. So diesels can be either V8 or inline. So if we remove the engine block, this is what you would see on the inside for the piston setup. So both a diesel and a petrol engine work on a 4-stroke cycle. So we'll talk about that in a second. So there's all kind of different configurations, like I said. So this is and that's like an inline 4 that's shown. You can have inline 6, you can have V4, V6, V8, even V10 and 12. So a 4-stroke engine cycle, like we mentioned, first you're going to have your intake, which is your piston is going to pull down and a valve is going to open, which is going to pull in either air or air-fuel mixture. Then it's going to compress by pushing the cylinder back up, and it's going to compress this mixture because both of those valves at the top will be closed. Then you will have an ignition. Then, after ignition, it will drive the piston back down, and it will come back up for an exhaust, which your exhaust valve will open at that point. Now, comparing the two engines. So, right here we have a diesel engine, and over there we have a petrol engine. So the difference is, a diesel engine does not have a spark plug. So the biggest thing that you're going to see on a diesel engine, whenever we come in right here, we're only pulling in air. We're not pulling in an air-fuel mixture. So this right here, this yellow thing is called a fuel injector. So at the point at which we've reached compression, we will have an injector that's going to spray fuel in. And these injectors, you're like, well, that's a lot of pressure. Well, a normal injector for like a diesel engine is going to be like 30,000 psi. So it's a pretty hefty little deal. But you might say, okay, well, if we don't have a spark plug, then how do you ignite fuel without some kind of ignition source? Well, you're igniting this because it's compressed at such high levels. So a diesel engine is going to have way higher compression than what a normal gas or petrol engine is going to have. So you say, okay, well, this spontaneous combustion normally happens at like a hotter operating temperature. That's cool. If you compress something really high, and then you also have a high temperature that's around it, it'll auto ignite. But what happens whenever you initially start on a cold morning? Well, that's when diesels use what's called a glow plug. If any of you have ever started, I know my dad had a diesel truck, and before you could turn the key, you had to turn it halfway, and this little light would come on, and it would stay on for like 3 seconds, then it'd go off. At that point, you could turn the key over and start the engine. Well, that little symbol right there is symbolizing your glow plug is warming up. So a glow plug is literally this little bitty probe that gets to almost 1,000 degrees. And what it does is it heats that cylinder up to operating temperature, so that way whenever that first stroke happens, you're at that temperature for that spontaneous combustion once that diesel and air is compressed. So going back to our lovely thermo class, you probably remember the Otto cycle and diesel cycle. So on your Otto cycle, you're going to have your compression from 1 to 2, at which point you're going to have a constant volume ignition. So once your piston is at top dead center, your air and gas will be at a constant volume. Then you're going to have a spark that's going to ignite, and then at which point it's going to expand back down, so you're going to decrease pressure, and it's going to decrease pressure even more whenever you have the exhaust. The diesel cycle is a little bit different, so we're going to compress way more. Like I said, we got that super high compression ratio on a diesel, and then we're going to have a constant pressure ignition. So we're going to hold the pressure constant, but we're going to increase the volume by injecting that fuel in, and then at that point it will have an auto ignition, and it'll come back down, and then you have your exhaust phase. So another way that diesels get super high compression ratios is the use of a turbo. So this is an example of like turbo. You can see it attached right there, and there's a diagram. I'm sure you've all seen how they work. So just a quick comparison: diesel cycle was 1897, auto cycle is 1876. Diesel cycle has lower efficiency and higher compression ratio. But then that's just thermodynamic terms. In the real world, a diesel engine is going to have better highway gas mileage. It's going to have more torque. It's going to be slower accelerating, but it's going to have better performance on the top end. So I can, once you get up to speed, you get that turbo on step, is what they call it. Diesel engines work better in a hot environment, but they can be used in cold environments that are just a little sluggish at first. And diesel engines are usually going to cost a little bit more per vehicles. So, any questions?